Hello everyone, welcome to the last module, the last chapter for this unit and for this course. It's chapter 13 and I've selected two sections from this chapter on solutions because I think they best fit with the previous concepts we have talked about in this course. In section 13.4, we're going to talk about solutions where a gas is dissolved in a solvent, particularly water. So we're going to talk about solutions with gases. And then in section 13.9, we're going to talk about solutions and how the addition of a solute or an impurity to a solvent can affect that solvent's freezing point and boiling point. You actually experimented with this concept of freezing point depression when you did the freezing point lab earlier in the course with regards to acetic acid and benzoic acid. So we're going to revisit some concepts from that lab in this section on freezing point depression. That's in section 13.9. Let's first talk about section 13.4, specifically how gases behave in solutions. So when we talk about solutions, we tend to use the term solubility when talking about if something can dissolve in a liquid. In the solutions lab earlier in the course, you saw a graph sort of similar to what you see on the left-hand side here. This graph shows you the solubility of particular solutes, of particular molecules in an amount of water, which is the solvent. So in this graph, you can see you've got solubility on the y-axis, temperature on the x, and generally speaking, with the exception of this sulfate compound at the bottom, generally speaking, as you increase your temperature, what happens to the solubility? What do you see those lines do? They generally have an upward trend. So that means that the solubility of those salts increases with increasing temperature. And that kind of makes sense, right? Usually you can dissolve more of a substance in a liquid that's hot than a liquid that's cold. So for most solutes that are solids, solubility, or how much you can dissolve in a liquid, in a solvent, increases with increasing temperature. Makes sense? But let's take a look at a similar graph, but with regards to not solid solutes, but with regards to gases. We have methane, oxygen, carbon monoxide, and helium. We again have solubility on the y-axis. The units for solubility are different, but it's still a measure of solubility. Temperature, so solubility on the y-axis, temperature on the x-axis. And in general, what do you see those lines doing? Are they trending upwards? No, they're trending downwards. They have a downward slope. So as your temperature increases, your solubility of the gas in that liquid solvent actually decreases. So that's a very important difference from solid solutes and gases. With gases, solubility tends to decrease with increasing temperature. Now, why that is the case, you talk about more in other chemistry classes. But this concept of solubility of gases decreasing with increasing temperature, you probably already knew just from when you boil ordinary tap water. So when you boil water, before that water reaches the boiling point, before you break apart all those intermolecular forces between water molecules to change the state of that liquid water from liquid to gas, you see little bubbles form. Those bubbles are mainly dissolved air, mostly nitrogen and oxygen, but mainly dissolved air coming out of solution. Now, once you get to the boiling point of that liquid water, the majority of the large bubbles are due to water vapor. But those smaller bubbles that you see when you boil water before you get to its boiling point, those are due to dissolved gases coming out of solution. They are decreasing solubility because you are increasing temperature. So, you should know that for gases, solubility decreases with increasing temperature. That's different than what you see with solid solutes. So when talking about solubility of a gas in a solvent, it's, as we just said, it's temperature dependent. It's also pressure dependent. So the dependence of a solubility of a gas in a liquid depends upon what the pressure of that gas is. So you can envision that if I have a sample of gas molecules and I have some liquid down here, my solvent down here, and I've got some gas molecules above the liquid. Some of the gas is dissolved in the liquid. Some of it's above the liquid, not dissolved. If I increase the pressure of these gas molecules that are above the solvent, what's going to happen? Well, you remember from the gas chapter we just talked about, those gas molecules, when you increase the pressure, the molecules will increase in motion, increase in movement, and that will give them more opportunities to dissolve in the liquid, in your solvent. So, the solubility of a gas increases linearly with increasing pressure. So the mathematical expression that dictates that law is called, or that phenomena is called Henry's law. You talk more about it in Chem 1 if you take other chemistry classes. If you decide to do the bonus that is associated with this chapter for the Chapter 13 quiz, there is a bonus question about Henry's law. I give you everything that you need to solve the equation. But for the exam and for the quiz over this chapter, you just need to know that solubility of a gas in a liquid increases with increasing pressure. So the pressure dependence on solubility of gases and that temperature dependence, those are the two main topics, main concepts from section 13.4. In the next video, we're going to start to talk about section 13.9, which is on freezing point depression and boiling point elevation.